Determine the intervals on which the graph of G is concave down and increasing. So keep this in mind, that this is a graph of G prime. It is not a graph of G. So use this to help you find where G is concave down and increasing at the same time. So please don't think of this as finding certain areas where G is concave down and certain areas where G is increasing. I'm looking for both characteristics to be true at the same time. Okay, so this is a good thinking question. It is using an old concept, you know, the increasing, decreasing thing with a newer concept, concave up or down. So take a minute and think it over, and we'll check your answer in a second. And get an answer to this. So let's break this down into kind of two parts and see if we can get this sorted out. We want to know where G is concave down and increasing. Let's focus on the increasing part first. So let's see if we can, maybe finish this sentence. G is increasing. So I'll say G is increasing when G prime is positive. So I am looking for where G prime is positive. So what I've essentially done is I have restricted myself to areas above the x-axis only, right? Above the x-axis is the only place where G prime is positive. So that will be the only intervals where G is increasing. So I'm only looking at the upper part of this graph. I am not looking at the lower part at all. So I'm just going to scratch that out. So I've kind of narrowed the field a little bit, right? So then let's focus on the other part where G is concave down. So this is a little trickier, the wording here. If you remember the video, perhaps, I don't know, we'll see. See if you can finish the sentence. G is concave down when G prime is?
Negative.
Nope.
Or well, how's a negative 4? Is decreasing.
Is decreasing. So these little sayings, little phrases that fill in the blanks that I keep trying to give you, these need to be absolutely rock solid. Because if you look at it and you're like, okay, G is concave down when G prime is, I have no idea, then you don't know what to do, right? And it's just going to be shots in the dark about G prime and G double prime and what do I do? You know, we can connect them for sure, but you need to know your facts. So G is concave down when G prime is decreasing. So I'm going to restrict myself to the upper part of the graph. I'm going to look for places where G prime is decreasing. And I see a couple of them. I see one of them right here. And I see another one right there. Does that make sense? So for a final answer, we'd say something like this. Our intervals are -4 to -3. And 1 to 3. So those are the intervals we want. And we could say something like this. It really goes with what we were looking for. We'd say because G prime is positive and decreasing on those intervals. There we go. Okay, so how'd you do? Did you put it together? Were you close? Any questions? Was there any follow-ups of any kind? We're just good, huh? Give you a chance. Questions? Okay. Fair enough. Yes, sir.
Would it ever be helpful to graph G double prime?
Good question. So some people will do that. I feel like that can be a good thing to do, but I also feel like at the same time, that's going to help you with one thing, right? That's going to help you where G is concave down. Because let's see if you can finish this sentence. G is concave down when G double prime is negative, right? So I would say, based on your hesitation, I don't think that would have helped, right? And so you've got to know your facts. Whether you're looking at a graph of G prime, G double prime, or whatever, you've got to know what means what, right? So if G double prime is negative, G is concave down. If G prime is negative, that means G is decreasing. That means it's easy to get them confused, right? So whether you look at a graph of whatever, you've got to know what it is actually telling you. Good question. Okay, anybody else? Yes, sir, Alex.
If it doesn't ask you to elaborate on your answer, should you always do that?
Oh, the whole justifying thing?
Yes.
No, I think you should only justify if you're told justify your answer. But I always do it kind of force of habit in here just so that I know that you'll be asked that. So I'm like, let's just do it all the time for the most part. But yeah, if you're not prompted to do it, don't do it. You're wasting your time otherwise. Good question. Anybody else? Of course, if you do it right, Alex, it's not like you're going to like get marked off for that. So I just don't want you to waste your time. Anyone else? Good questions? Don't be shy. Okay, fair enough. Let's keep moving here. We'll do a little more work in this section before we... Okay, so a point of inflection is a location where the blank changes. One word, what do you think? Concavity. Concavity is what goes in there. Good. So this is where the graph of f or the graph of g or whatever goes from being concave down to concave up, or concave up to concave down. So in both cases, you would have an inflection point right there in the middle, somewhere, maybe like right here, or maybe right here. Those would both be inflection points on those graphs. Concave down to concave up means that you had an inflection point. Okay, so by the way, all these little sayings that I keep kind of quizzing you on a little bit, like when G prime is positive, that means G is whatever, you know. All these things are I think, pretty well presented at the end of your notes in the extra resources section. Little flow charts and all kinds of stuff, hopefully presented in different ways than you saw in class. It's also summed up in the key takeaways in each little section too. So anyway, yes, sir.
For points of inflection, isn't it also where the slope, where f prime stays the same, like if from positive to positive to negative to negative?
Only if the point in the middle is a critical number. Right? So if you just say, hey, over here f prime is positive, and over here f prime is positive, therefore we must have an inflection point. Well, that's only true if you had a critical number in the middle, right there in between those two sections you referred to. Yeah. Okay, so that's a good question, and that's kind of a first derivative test question, right?
Yeah.
Okay, so let's look at these two sayings, see if we can reconcile with what you just said. Two ways to justify an inflection point. An inflection point on f occurs when f prime changes from increasing to decreasing, or vice versa. Okay, so an inflection point on f happens when f prime goes from increasing to decreasing, or decreasing to increasing. Or, I like this one a little bit better because it's simpler. An inflection point on f happens when f double prime changes signs. I hope you can see that that's really saying the same thing. So let's think this through. If f prime is increasing, isn't increasing referring to a positive slope?
Yeah.
So if f prime has a positive slope, what is the slope of f prime really?
Increasing.
Isn't it the derivative of f prime? Like the slope of f prime is really f double prime, right? Think that through. So what this is really saying then is that the slope of f double prime is positive. And then it's saying if the slope of f prime is positive, which means that f double prime is positive. Well, if f prime is decreasing, then that means that f double prime is negative. So it's saying that f double prime changed sign. So these two statements really are saying the same thing. They're just using different terms, right? So bottom line is, if you're given a graph of f prime, you should consider using the first wording. I think that that's easier. These are both debatable sentences here. But if you're given a graph of f or f double prime, I would encourage you to use the second wording. I say all that to say you might disagree and say I'm going to use this, and that's okay as long as what you write is correct and justifiable. Then it's totally okay. So we're going to try to use these thoughts here with example 3. It says find the points of inflection. We can also discuss the concavity of this graph. Main thing is we want to find the points of inflection. So I gave you a graph of f. So according to my advice, if you're given a graph of f or an equation for f, we should use the second wording. The second wording deals with f double prime changing signs. So what would you guys think to do here with this?
Find the f double prime.
Yeah, find the second derivative. So that means find the derivative and then differentiate it again. So let's go ahead and do that. A little practice, a little warm-up after the break, doing some power rule work. Let's give it a shot. I will quietly work on this one up here. And double check our second derivatives there. Make sure we're all doing okay. That work? Okay. Okay, so we're kind of shooting to find where f double prime changes signs. If we're looking for that, what might we want to do with f double prime in its current form? Set it equal to 0, right? Because that'll tell you where f double prime is 0, which divides the positives and the negatives. So that's what we would do. So I'm going to say equals 0. Solving that, obviously, pretty simple stuff. X equals 1/2. Okay, so x is equal to 1/2. That is where f double prime is 0. That is not a guarantee that that's an inflection point. All that really means is that f double prime is 0 there, because you know that f double prime could be 0 and not change signs, right?
Yeah, like it was on the example.
Exactly. So let's check this out. How could I check this out? What graphic could I use?
Use the sign chart.
Sign chart, yeah. So that's what I'm going to do. I'm going to come over here and do a little f double prime sign chart. And the only number I'm going to put on there is 1/2. That's where f double prime is 0. What would be a good test value for the left interval?
A quarter.
Yeah, a quarter. Yeah, I'm going with 0, but a quarter would work. Wouldn't be that bad because you got a 12, but yeah. I'm going with 0. So f double prime of 0, -6. Anybody want to try a strange one for the right interval? Or go with 1? Love your creativity there. Okay. So based on what we've got up there, is x equals 1/2, is that an inflection point of f?
Yes.
Yes, it is. So we would say this. F all right. F has an inflection point at x equals 1/2 because f double prime changes signs at x equals 1/2. Okay. Doing okay still? Any follow-ups? So again, it didn't say to justify your answer, but I'm using that wording, because f double prime changes signs. I really am justifying it. Just want you to be in that habit because you'll frequently be asked to do that. Any follow-up questions at all?
Well, we're supposed to discuss the concavity.
Oh, sorry. I forgot about that part. Let's do it. So looking at this, you can really tell all you need to know from what we did earlier with our sign chart, right?
Yeah.
Where is f concave up?
After 1/2.
1/2 to infinity, right?
Yeah.
And f is concave down on the left interval, right? From negative infinity to 1/2. Yep. Okay.
So it goes from concave down to concave up.
Correct. F goes from concave down to concave up. Any other follow-up questions? These are all really good. Comments, thoughts, questions? Clarifying thoughts of any kind? Okay. Moving on. Let's see let's notice what we were given here. It says, given a graph of f prime. If I were you, and I really mean this, taking tests and quizzes can be a little scary. Scary as far as trying to remember what you're given and what you're trying to do. Seeing that you're told this is a graph of f prime, I would write that down. I'd make a big deal about it. I'd circle it. I'd underline it and say, because think about what we have here. So far we've seen graphs of f, f prime, f double prime, and they're all connected, but they all mean different things, right? And so I would make a big deal, say this is not a graph of f double prime. It is not a graph of f. It is a graph of f prime, and that carries with it certain meanings. And so you want to make sure that you understand what you're given so that you can hopefully assign the correct meanings to it. So given the graph of f prime, determine the inflection points of f, and we're supposed to justify our answer. So I'll give you guys a chance to do this. You got those definitions earlier of inflection points. If you know those, that's pretty doable. If you don't know those, which, why would I expect you to have them mastered now? But, eventually if you have them mastered, you should expect to be successful on something like this. So take just a moment to do that, and this will be our last one for the day. Hey guys, you've had plenty of time to chit chat. Let's get going. So Luke, let's hear. You guys were discussing a lot. I kind of was eavesdropping a little bit and watching you guys. You guys were discussing a lot. What did you come up with for a conclusion?
So I'm not super confident in this, especially because I didn't use f double prime at all. But I said the inflection points are at x equals -1/2 or negative 1 1/2 and negative 1/2, because that is when f prime changes from positive to negative.
So negative,
Changes signs.
negative 1.5
And negative 1/2,
and negative 1/2.
because that is when f prime changes signs.
So we're basically looking at this point here and this point here.
Yeah.
Does that sound about right? Okay, what do you guys think? Is that correct?
That's fair.
Oh man, you're getting some pretty negative responses here.
Luke, I love you. Come at us, guys.
Okay, so those of you that said, no, I don't think that's right,
Okay.
I will say this. Luke, and maybe his group, maybe it's just Luke, I don't know. He found something, didn't he?
Yeah.
Can anybody explain? This is a key point for you, for everybody, but Luke in particular. What did he find, Ben?
Is it where the, that's something to do with the F graph, right?
We could all we could trace all of this back to the F graph. Yep.
Extrema, right?
It's relative extrema. Look right here.
It was a turning point.
Right here, isn't that where f prime went from positive to negative? So that would mean that f has a relative max. And then over here, this is where f prime went from negative to positive, therefore f has relative min. So you found something, and something important actually, but it's not what I asked for.
Yeah.
Okay, so let's backtrack a little bit and see what else we can come up with. Any other suggestions on inflection points of f? What do you think? Drew, go ahead.
I would say -1, at x equals -1, and about
Keep it simple, Drew.
2.
2, there we go. Right, let's not get into the 1.9764.
Actually, it would be
3, 5. Let's not do that to ourselves. Let's go with whole numbers here. Okay, so Drew came up with these numbers. Maybe his group came up with these numbers along with him. What do you think about these numbers? Are these better? Halfway there? All the way there? What do you think? All the way there. Okay, so Alyssa, you guys, I noticed, came up with these numbers as well, right? Okay, so what do you guys think? How could you justify this? Because it does say justify your answer. I'll say, x equals -1 and x equals 2 because what?
F prime changes from decreasing to increasing at x
Excuse me, please excuse Tiffany Parobeck for the day, please.
Why Tiffany? Why Tiffany?
We just won't start bringing them.
Better hurry over and respond. I don't want to have them be mad at me. Did you hear me? Tiffany is on her way.
Thank you.
Okay. So Drew and Alyssa have put it together correctly. Yeah. So are you starting to see the importance of having like these justification type sayings solid, right? If you don't have those, then honestly you don't know where to start. That makes sense? So you see something like this, hey, where are the inflection points of f? You need to think, oh, that's where f prime goes from increasing to decreasing or vice versa, or f double prime change signs. Anybody use the f double prime wording? You could have, right? But it's best, I think, if you have an f prime graph to use the f prime wording instead of the f double prime wording. Could be your choice there. So, okay. Any follow-up questions? Okay. I think we'll leave it there for now.